Hi friends, we'll solve problem on work energy principle. What is given in problem? Two springs each having stiffness of 0.5 Newton per centimeter are connected to a ball having mass of 5 kg in a horizontal position, producing an initial tension of 1.5 Newton in each spring. If the ball is allowed to fall from rest, what will be its velocity after it has fallen through a height of 15 centimeter? Now in this problem, number of springs involved are two springs. Initial position horizontal. See, this one is initial position here. Springs say AB and BC are in horizontal position. Length of spring is 20 centimeter for each spring. AB and BC having same initial length. But initially what is given? There is initial tension in each spring. Now when tension is developed, that means a type of forces which are acting on the spring are a pull type of force. Therefore springs are in tension. As spring are in tension, length of spring, what you are getting here, what is given is 20 centimeter, is definitely greater than free length of spring. Therefore in this problem, free length of spring is not given and deformation is also not given. What is given, important part here, is initial tension in each spring 1.5 Newton. Value of K, spring constant, is 0.5 Newton per centimeter. What is the meaning of this one? When deformation of spring is 1 centimeter, then spring force developed is 0.5 Newton. And initial tension, what is given in problem? Initial tension. Now this initial tension what is developed in spring is also what? Spring force Fs equal to 1.5 Newton. As initial tension is given, spring constant is given as 0.5 Newton per centimeter. That means you know relation between this spring force and K is what? Fs equal to K into X. But now this is initial position, therefore what X you are getting here may be written as X1. Spring force is equal to 1.5 Newton. K is 0.5 Newton per centimeter. I am writing here units also so that easily will understand what to get from this one. Now as this one is Newton, here also Newton, Newton gets cancelled. What will get X1 is in centimeter. X1 comes out to be 1.5 divided by 0.5, that means 3 centimeters. That means initial deformation of spring, particularly here initial elongation of spring is 3 centimeter. This one you will get easily if you see carefully. K is 0.5 Newton per centimeter. That means when deformation is 1 centimeter, spring force developed is 0.5 Newton. If deformation of spring is 2 centimeter, spring force developed will be 0.5 into 2, that means 1 Newton. Again deformation if will increase by 1 centimeter, that means 3 centimeter. Spring force developed is 0.5 into 3, that means 3 centimeter. So for 3 centimeter deformation, spring force developed is 1.5 Newton, or using this equation easily will get what? Initial deformation. Now what is known? At initial position, length of spring what is given? Length of each spring, right? That is 20 centimeter. As length of spring is 20 centimeter and initially spring is in elongated state, where elongation of spring is 3 centimeter, that means free length of spring is less than 20 centimeter. If you find out here what is free length of spring, so can you say free length of spring is initial length is 20 centimeter and what deformation or elongation of spring you are getting is 3 centimeter. That means 20 minus 3, which is equal to 17 centimeter. Now free length of spring is 17 centimeter. Initial deformation is 3 centimeter. Now to find out final deformation, just see figure what is given. In this figure, initial position is horizontal position. That means this one you can say is what? Position 1, this horizontal position. Final position is nothing but position 2 when this ball falls in downward direction by 15 centimeter. This is position 2. Now as you are getting position 1 and 2, at position 2, if you want to find out what is the deformation of spring, for that one you must know actual length of spring, may be AD or maybe CD. To find out this length AD, if we will apply Pythagoras theorem, this length horizontal is 20 centimeter, vertical is 15 centimeter. Therefore, actual length of spring here is standard triangle 20 and 15. That means this length comes out to be here 25 centimeter. Free length just now you have calculated is 17 centimeter. Therefore, actual length of spring is 25. Free length of spring is 17 centimeter. That means deformation of spring comes out to be 25 minus 17. Therefore, final deformation of spring, final deformation, if we write final deformation of spring as x2 is equal to actual length of spring in position 2 is AD, which is equal to 25 minus free length. That means this one comes out to be 25 minus free length is 17. That means x2 is 8 centimeters. Now in this case, x1 and x2 were written in centimeter, but if you apply work energy principle, x must be in meters, k must be in Newton per meter. Therefore, this value of k, what is given, 0.5 Newton per centimeter. If you want to write in Newton per meter, 0.5 Newton, 1 centimeter means how many meters? So 1 by 100 meters. Therefore, 0.5 into 100, this value comes out to be 50 Newton per meter. X1, what we are getting here is 3 centimeter means 0.03 meters, and x2 is 8 centimeter, that means 0.08 meters. That means x1, x2 is known, k is known. Now if we'll concentrate on work done by forces, so what we'll get in work done by forces? Mass of this ball B is given, where mass is given as 5 kg, where this weight, if I'll represent here, weight acts in downward direction, where weight becomes 5 into 9.81 means g. Now as the ball moves in downward direction by 15 centimeter, weight is also acting in downward direction, work done by weight is positive. Therefore work done by weight, if we write, it is positive, plus 5 into 9.81 into 0.15 meters, work done by weight positive. To find out work done by spring forces, we will use formula half k x1 square minus x2 square. X1, x2 are ready now. But when you apply work energy principle, you have to concentrate, number of springs are 2, therefore work done by spring force becomes twice into half of k x1 square minus x2 square. Again at this position 2, you have to find out what is the velocity of this ball. That means say this is what v2. At position 1, this ball is released from rest, that means v1 is 0. Now unknown term is only v2, where applying work energy principle will find out velocity at position 2. Applying work energy principle, just on next page will continue. Applying work energy principle from position 1 to 2. If we apply work energy principle, first term is work done by all forces when body moves from 1 to 2 equal to ke2 minus k1. Now in work done, you are getting work done by 2 spring forces plus work done by weight. Work done by weight is mass into G into H, means vertical displacement. By spring force, work done is half K x1 square minus x2 square equal to half m. Kinetic energy is V2 square minus half m V1 square. Mass of this ball is given as 5 kg. G is 9.81. What vertical displacement is given is 15 centimeter, therefore 0.15 plus half. K value must be newtons per meter, where it is now 15 newton per meter. X1 value what we are getting, initial deformation is 0.03 meters minus final deformation is 8 centimeter, means 0.08 meters, equal to half. Mass is 5 kg, V2 square minus initial velocity is 0, therefore initial kinetic energy is 0. Substituting all values, if you calculate what is the velocity of ball when it falls through 15 centimeters in downward direction, if you calculate using calculator, V2 comes out to be 1.683 meters per second. Now while solving this problem, this part represents what? Work done by spring force. But this formula is for work done by only one spring. But here number of springs are 2, therefore you have to multiply here by 2. Similarly here, same work done by spring force, here also this must be multiplied by 2. Number of spring in some problem may be given as 3, so we'll multiply it by that much number of spring, provided its K value, initial deformation and final deformation, if it is same. Otherwise, for each spring we have to write these values separately, half K initial deformation square minus final deformation square. As number of springs are 2, if you multiply here 2, then we will get correct answer, and velocity of this ball when it falls through 15 centimeter comes out to be 1.683 meters per second. Thank you.